Okay, well here's the last FRQ from the mock exam. And looking at this graph and looking at the words in it, a couple of key things that you want to underline and make note of. First of all, we're told that this graph is 3-line segments, so we can assume linearity, and we're also told it's a semicircle. Fantastic. Now we're also given this function. Now according to this, when we would take the derivative of g, that would be equal to f. So I could also label this graph as the derivative of g of x. Now I'm sure that will help me further. Now we are asked in part A to find g of -6. So g of -6. Now looking at part B, we are asked to find g prime of 0. Well, again, realizing that this graph is the function of f, or another way to say it, it is the graph of g prime. So we want to find g prime of 0. So when we look at the graph, when the input is 0, the output is 2. So then g prime of 0 is equal to 2. And if you got that correct, that is worth 1 point. Part C. Now in part C, we are asked to find on the open interval. So notice we do not have to consider the endpoints, for which g has a horizontal tangent. Now horizontal tangent just means when the slope, right, tangent of a slope, the tangent line, the slope is equal to 0. So looking at this graph then, where is the slope equal to 0? So this is the graph of g prime. So where is g prime of x equal to 0? Well, we don't include the -6, but we would include then the -2 and the +2. Okay, so we would say at x equals 2 and x equals -2, the graph of g has a horizontal tangent. The graph of g has a horizontal tangent. Now this next part is asking about maximums and minimums. Okay, now in order for a graph to be a maximum and minimum at these horizontal tangents, the sign of the derivative must change. So we notice here at -2, you'll notice that the g prime is positive, g prime is positive, and then g prime is negative. So at -2, there is not a max or minimum because g prime does not change signs. So we could say at x equals -2, there is no local max or min okay, because g prime x, which is equal to f of x, does not change sign. Okay, now we'll use the same reasoning when we look at x equals 2. Now you notice that x equals 2, it does change sign from positive to negative. Therefore, we have a local maximum. So we say there is a local max because g prime x is equal to f of x. G prime x is equal to f of x changes sign from positive to negative. There we go. Fantastic. Now let's go on to the last. Okay, now the last part, we're looking again at the open interval, and we're looking for which there is points of inflection. Now we know points of inflection are always second derivative. G prime of x is equal to 0, or it does not exist, right? Sorry, 0, not a 6. So we're going to look at the second derivative. Now this is the graph of f, or the graph of g prime of x. So to look at the second derivative, we would look at its slopes. So where are the slopes 0 or undefined? Well, we can see right here at this point we have a corner. So that slope is undefined. Now we also have a corner here at -2, or sort of like a cusp, huh? But that's undefined. And then the last place then that we have a slope of 0 is right here at 0. And that is a horizontal tangent line, so it has a slope of 0. Now those are all three possible points of inflection. Now remember, a point is not a point of inflection unless it changes signs. And what changes signs? Unless the second derivative changes signs. So at x equals -4 and at x equals 0, the second derivative of g changes sign from positive to negative. So therefore, these points, these are points of inflection. Okay, now let's justify at x equals -2. And we can say at x equals -2, g double prime of x is dne, and the sign of g double prime x changes from, and what does the sign change from? It changes from positive, no. At -2, we're changing from negative to positive. Now something that I like that I wrote more clearly in the second explanation is I made this statement first. So I'm going to go up to my first statement and add that too. So at x equals -4 and x equals 0, we would say g double prime of x equals 0 or equals 0 or dne, and the second derivative changes sign from positive to negative. There we go. Now we have a very thorough explanation. Now you could also say, excuse me, you could also say, instead of saying the sign of the second derivative is changing, you could also be saying g prime of x equals f of x, and this changes from increasing to decreasing, which also would be a justification for it being a point of inflection. So I hope this helps and makes a lot of sense.